but I know it's there. There's a shore in the middle of the storm we could rest upon. I don't see it yet.
Good evening, Smars fans. How are you doing? Hope you're having a really great evening. So what a week it's been this week. I've got so much to fill you in on, and we can catch up on where we're up to with the Getting Started with Robotics Series 2. So do you want to build a robot? Don't know how to start, what you'll need or how to do it? Then you're in the right place. So if you stick around as well, I'll show you the forklift module I've been working on. I've just literally had some parts arrive late this afternoon from Amazon, and I can talk about that slightly later on. And I'll also give you a quick update on the studio build as well, the Robot Lab build. So let's get over to the video. So my name is Kevin. Come with me and learn as we build robots, bring them to life with code, and have a whole load of fun along the way. So this week we're recapping the last couple of weeks and looking at the next steps in our Smars robot build. We'll be looking at where we can take this next. So I've got another little video I've prepared for you. Let me just put this one on now. So this is a quick recap over the last couple of weeks. Over the next couple of weeks, we'll be looking at every aspect of getting started with robotics, everything that you'll need to have, to know, to build, to get there. This week, as I said, we're looking at printing out the parts, we're downloading the STL files, finding the instructions, deciding which files to print, slicing the files with Cura, 3D printing, looking at 3D printer settings and how to use Octoprint, and we'll also be looking at preparation, how to level the bed, choosing the right filament colour and so on, and then printing the parts as well. Week 3 is all about assembling the parts and doing a bit of soldering for the motors as well. So today we'll be wiring up the electronics. This is all about the code today. So over the past couple of weeks we've been printing out the robots, we've been wiring up all the electronics, we've been looking at how you go about assembling the robot as well. And today it's all about how we get code loaded onto our Smars robot. Just noticed the description tag that was on the video there. I used a lower third in Final Cut and only used one part of it, so that must have been left on there. Never mind. This is what happens when I do things in a rush on a Sunday to try and make a more interesting show for you guys. I hope you like that little video. Let me know if the audio is a bit peaky. That looks a little bit going into the red on my sound gauge there. I'm always conscious that I've not quite got the sound right, so maybe I'll just be a little bit further back from the microphone. So without further ado, let's get over to Keynote and let me share my screen as well. Okay, so this is all about the recap, where we're up to, what we've been covering off. We covered a hell of a lot of stuff in the past couple of weeks. We're just looking through all the content that we've gone over. Yeah, we've done quite a bit. And what I'm interested to know from you guys is the pace of this right? Do you want me to do this slower? Is it just about right? Would you actually like it a bit faster? I know some YouTube videos I watch, some of the narrators are very slow in when they talk, and I actually put it on like 1.5 speed on the speed setting just so I can get through it at a reasonable pace. It's like speed learning or something. So if we look at what we did over week 1, we kind of laid out the journey, didn't we? We looked at how we were going to cover building a new robot, a Smars robot from scratch, and everything that we needed to do. So we looked at printing all the parts using a 3D printer. We looked at assembling the parts, looked at wiring up the electronics, loading the code into the Smars, and then this week we're looking at next steps and having a bit of a recap. So yes, in week 2, we covered things like, where to get the files from and download them. There's quite a few different places we looked at to get instructions from. So there's the actual Thingiverse files, the original source of Kevin Thomas's files. And then there's also smarsfan.com, which I've created, which helps to bring together more content in a kind of English language first website. And then we looked at, which file should we actually print. So we went for the Smars wheeled robot. And if I just flick over to my little desk here, one of the things I've got here is the quad robot. And I think what we might be looking at for the next series is building the quad robot. It's a little bit different in that it uses a Raspberry Pi Zero rather than the Arduino. We could look at using an Arduino to drive it, but I was thinking about we could do some really interesting things with vision. So maybe we actually get round to doing that with the quad robot. So that's something that we can, as a future direction, we can take Smars in. But let's get back to our screen share. So yes, in the series we looked at the wheeled robot. It's a much easier build to start with. It's what most people build with. So that's what we took. Then we sliced the files in Cura. There's many different 3D printing packages out there. Cura is one of the most common ones. It's being developed commercially but given away for free. There is Simplify 3D, which I believe they're working on a version 5 at the moment. I do have Simplify 3D on my Mac. However, it's quite an expensive package for what it is, but if they are reinvesting in the the code and making it even better, then it should be good. We should see good things from that. And it's just down to the features and the ease of use. What does it mean to you? Because typically I just want to throw an STL file in there and just get the G code out of it. I'm not really bothered about tweaking settings so much. So then we looked at the 3D printer settings, curiously enough, and printing that with Octoprint, which is what I use on my 3D printer to control the 3D printer. So it's a little Raspberry Pi that's sort of plugged into the USB of the Ender 3 Pro, and it controls it. It means I don't have to worry about my other computer doing anything else. It's quite a low cost way of running a 3D printer. So, and then we looked at preparing the printer itself, leveling the bed, choosing the right kind of filament and colouring, and we had a cheat sheet that that's on the website if you want to look at that, where you can download and colour in if you want all the different parts of your robot, so that you end up with quite an interesting colour build. Because what's quite frustrating is when you just print it on one solid colour and then at the end you think, I wish I'd have printed that in another colour. It just requires you to sort of change out the filament, and that can be easy or complicated depending on your type of 3D printer. And then we looked at printing their parts themselves. So what's involved in doing that. So we did actually print out kind of in real time, as it were. Over the 1 week I printed out all the parts, and it was about 31 hours I think worth of printing, so that we could actually get a robot that we could put together. And I did it in a few different colours just to make it a bit more interesting, and it didn't go right first time. We did have quite a few failed prints. I've got them to hand actually just here, and I've got more on that actually later on with the forklift as well. I want to show you that too. I always think it's good to sort of show, the real world and how things can happen. So I printed out these little motor holders. I'll just put my hand in the way there so it can focus. You can see there it's sort of bent up. It's not adhered to the bed very well. And similar with this is even worse. This one. So this is the rangefinder holder, and you can see there where it's just not adhered to the bed and it's sort of curled up at the edge. It's warped. And what that was to do with is I'd not properly levelled the bed, and I was having a few issues with my 3D printer. There's a BL Touch, which is a little module that pops down to sort of sense where the bed is, and it takes 9 readings, 3, 3 and then 3, so across the board in a grid pattern. Excuse me, and then it can figure out, if the bed needs any sort of leveling, and it will apply a mesh to the bed, which when it's printing, it applies that height difference, so that what you get as a print is pretty much perfect. That's the theory. The problem was that assumes that the bed itself is perfectly flat, even if it's at an angle. The surface is flat, and this is the Ender Pro. Build surface. It's a magnetic surface. It's actually on a piece of magnetic thing there as well, and you can see there's as well as being quite worn, there's some gouges in it. There's a great big gouge there where the head went into it, and in the actual middle there's a little divot. I don't know if you can see that little divot just there. And that means that when it's doing a sensing, it drops a bit further down. The whole overall, the surface just wasn't flat. And that meant if you printed something here, it would be nice and perfectly flat onto the board. And then as it got over here, it sort of lifted off a bit and you would end up with stuff just not sticking there. So I thought it was time to get another one of these. So they're about £20 to buy. They're not actually quite cheap. So I put another one on, and that's much better now. So, and I also reflashed my firmware on my printer, so it's now running Marlin 2. That wasn't trivial. Should have done a video on that one. So quite a lot of learning went into the printing of the parts for me, and what I've ended up with is pretty good quality print. So if I just get the robot here, if you look at the face there, if I can get that into focus there, the speckle effect is actually, the filament is a diamond sparkle, so that's actually intentional, but the surface itself is very, very smooth. If I compare that to like another one that I printed much earlier on, you can see that's all very rough. It's got bits that are shiny but bits that are not. So the quality of the print is quite better. If you look at the wheels on this one, if I can get that into focus, ignore the one with the bits of red on it, that's just where I didn't pull something off. But that's actually quite good. And you can see as well on the tracks, the black tracks are quite shiny. Again, that's a nice flat surface compared to previous one. I don't know if you can see they're a little bit rougher, quite a bit more imperfections. So I've got that dialed in a bit more, and I dialed it in because we were doing these sessions, so I wanted to make sure it was as good as it could be. So that's what we did on week 2. And I was thinking, if you haven't got a 3D printer, I wouldn't want that to be a blocker for you getting involved in building your own Smars robot. There are ways around that. And one of the ways around that, if I go over to our screen share for a second, is there are 3D printing services available. So you can go online. I've heard of 3D hubs before. I didn't hear of makeitquick.co.uk, which is a UK-based one, or iMaterialize.com or craftcloud3d.com. None of these are sponsored. I don't get any kickback or anything like that. God forbid from these things. I was just looking around to see, how could you go about uploading an STL file, and then in a couple of days / weeks time, you get the parts printed, and hopefully quite professionally so as well. So there's none of the headache. You just get, perfectly printed robot part. So I've got a question there just from Sid. I just want to answer that now while we're on the topic of this. So you're saying, is that PLA? Yes. So I used PLA. You're probably referring to this warped piece that I've got here. It is PLA, it's not ABS. ABS is quite prone to temperature changes. Now, one thing I will note is there is a radiator right next to my 3D printer, and I do have a patio door that opens and closes quite a few times during the day. And they can make the temperature change quite significantly very quickly, and that can affect your print. So it's a relevant point to raise about the PLA, but I do tend to go for PLA. The issue that I had with, well, I'll come to the forklift bit in a bit. There's quite a bit of an epic about that one, but that one had quite a few faults, and it was actually to do with the reel, which I've got in the box down there. The filament had sort of got itself crossed inside the spool, and what happened was it got to a point where it couldn't pull it off the reel as it's printing. It's sort of continually pulling it off the reel, and it's just on a little spool holder, and it got to a point where it locked that tight that it just pulled it and snapped it off, and ended up just printing in space, so that there's nothing coming out the end. So that was great. That wasted several hours. I've replaced that now with some brand new filament, and we can actually see on the print, if I just pull up one of these pieces, I think it's this one, is it? Is that one? Which one is it? Well, it was one of these two. You could actually see that it changed midway through. It must be another one. Really, did I print that many? Hey ho, I'll come to that shortly anyway. So yes, you can buy, it says me too, you can buy the robot parts basically online. You can just, I'm not sure about the cost of that, and I guess the more that you send, the cheaper it'll be, but completely speculating there. 3D printing isn't cheap. I mean, it's cheap once you've got the equipment and you've invested that effort setting it up and you've got it the way you want. Then you're just paying for the filament, and if you've got a big roll of filament, that could last you, quite a long time. You can print several Smars robots in full from a single 1 kilogram reel. So you get the value for money once you've bought the thing, but an Ender Pro 3 is what, £250, somewhere thereabouts, so that's not cheap. You can buy ANET A8 or Prusa 3 clones, i3 is it called, and they're really good printers. So I had an ANET A8 as my first printer. I gave it to one of my friends once I'd done with it, because I didn't have space for two. I will have, ironically, space for two once we get the robot lab built anyway. So yeah, it's not cheap to begin with, and if you're just buying these things from a site like that, you're kind of paying for the fact that they've already set up and they've got experts and blah blah blah. So it's an option. It's something that you can look at if you haven't got your own 3D printer, but it's worth the investment if you're going to do robotics for any amount of time. You can design your own parts, which is one of the most rewarding things that you can do, is to design something in a 3D package, print it out, and then actually have something that you've made, that you've thought of and you've designed, come out. So definitely worth investing in one if you haven't got one already. So then week 3, we looked at assembling the parts and soldering. I did some live soldering, which was a bit frightening. I was expecting to burn myself or just set something on fire. I was having to do some soldering today, and I thought, should I get out the soldering iron or should I get out the... I have one of them gas-powered, butane-powered soldering irons as well for doing very quick things, so I just use that. But in fact, Adam Savage has recently done, on tested.com, he's done a video about producing a workshop soldering iron station, and it's kind of all in a big tower, and he uses DeWalt batteries, DeWalt drills and things like that. So he uses a battery pack from that to power a USB soldering iron. So very interesting developments that you can do with soldering, but I did some live on the video, which was fun to do. But we made it, we soldered the motors, and they do work, so it was a job well done. So then we cut the wire, that was a really complicated thing for us to do. We soldered the motors, we attached the battery, got the whole thing up and running from a sort of electrical point of view. We did look at some of the motor shields in that one, and then we followed that up on the week 4 actually. I think we looked at some more of the motor shields and how they differ, because that was one of the questions that came up. Who was it who was asking about, was it Taylor who was asking about this particular motor shield that's got the 3 chips on it? And the issue I have with this particular variety of one is that it doesn't actually have any header pins on there, so you can't plug anything into it. But I have got one of those. What is good about this one, and this might be useful for the forklift one, is it does have more than one motor, so more than 2 motors, so you can have, because you need a third motor connector to drive part of the forklift, so I'll get to that shortly. So some of the soldering tips I would recommend is always use a clean soldering iron. So there's a number of ways you can clean it. If you have a little sponge with water on, you can dip the nib in that and sort of, wipe a bit like a bird wipes its beak, sort of wipe the nib of the soldering iron so it's nice and clean. I sometimes use like a rasp to file off any bits, so that again you've got a really nice surface. There's no kind of crud or burnt bits on there that are then going to transfer onto your parts. That's the last thing that you want. And then you need to prepare the parts. So when you solder them, if the electronic parts, I'm just looking around to see if there's any I can show you. If there's any parts that have been sat around for a while, they will tend to oxidize slightly on the outside, and you don't want that. It means that the solder won't adhere to it or sort of bond to it very well. So you can rough that up. Sometimes if you just get some pliers and just sort of strim and make it a bit shiny, then the solder's got a really good connection, sort of mechanical connection to make there. So I usually rough it up, get rid of any oxidization, dip it in some flux, and then when I attach the solder, it just perfectly goes on the part. And if you're using wires, just tin them as well, just apply some solder to the end. It again just makes a really good fit. So that's I wonder what happened there on my screen. Something weird just happened down there. Don't know what that was about. So yes, that's what I would always recommend to do. Just make sure you've got a nice clean soldering iron, make sure the parts are all prepared, and then tin the wires, use flux. So then we wired up the electronics. So we looked at motor shields, we looked at how we can connect the rangefinder, and we wrote a little program called Follow Me, which I put on the link to last week's video. There's a GitHub, and we actually go through some of the code as well, line by line. And that was quite a fun program. It sort of made the robot go backwards and forwards depending on the distance of an object in front of it. So you can have a whole line of them. I intend to do a video on this if I can. A whole line of robots all sort of keeping their distance from the one in front. So if the front one was like a Bluetooth one, Bluetooth control one, we could control the whole thing. So that's a whole load of fun. Connected up the motors and the batteries, and we looked at what the pinouts were for both the AT Mega chip as well as the Arduino. And when we look at the Raspberry Pi Zero, or the Raspberry Pi in general, we'll have to look at the pinouts on that as well, because they're very slightly different, but it's the same kind of thing. We have, the usual kind of GPIO, some are analog, some are digital, some are PWM, and so on. So the Raspberry Pi's got a slightly different arrangement of them. And we looked at some other options as well. Looked at line following, looked at Bluetooth, and the gyros as well, that can sort of look at the orientation. We did a whole load of videos on coding a couple of weeks ago, so if you look through my channel, you can probably find them about bringing it to life with code, I think it's called. And then yes, we looked at choosing the right motor shield. So as I was saying, that when you buy a motor shield, there's all pros and cons. Sometimes they're quite cheap, sometimes they're a bit more expensive, and they have different functionalities. So some of them have built-on buzzers and dedicated headers for Bluetooth and the rangefinder module, like the Fujimoto one that I prefer. There's the official Arduino one, which works with all the libraries straight out of the gate. So if you go to any official Arduino sketch, they will work guaranteed with their motor shield. And we looked at what the differences were on that, and how we can write one block of code and just have one setting within the code for any type of motor shield that we come across. So that's what we looked at from the motor shield point of view. And then we looked at loading the code in as well, and the follow me code, how all that can work. So we plugged it in, we got it working, we did a bit of live interactivity on the desk there, and that was good fun. I know this is one of the areas where people struggle the most, so I'm thinking about how we can expand that and delve into it more, just to get people more familiar with programming, and get around some of these issues that's a blocker for them. There's quite a lot of things that you have to know to get into programming, that if you already know these things, you just take it for granted, and that's part of the learning process for me too. So we might come back to, well, we definitely will come back to doing some more code, both on the Arduino and also in Python as well, which is my favourite language. So yes, we looked at the Follow Me program. If you want to get a hold of that, it's github.com/KevinMcAleer/follow_me2. Follow_me was a different variety of it, and the _me2 is the best version of that. So you can see that it measures the distance. If it's greater than 10 centimeters, as in nothing in front of it, it'll move forward. It will stop if that distance that it measures is between 5 and 10 centimeters, and if it's less than 5 centimeters, because the object in front of it is moved towards it, it will back up. So that's what the sort of pseudo code for that program is, and that works pretty well. It doesn't turn round; it just goes backwards and forwards. So that's worth thinking about too. And here's some of the parts that we used to build our first Smars. So we had the rangefinder, the HC-SR04, which is a very common module. I was talking to somebody on Instagram this week. Is it PyBot? And he was sort of saying it's like the face of the robot. It's it's quite a famous component because it's always used as the sort of face of the robot, because it does look like eyes. And one of the things I love about Smars is it looks like a cute little face on there. Though when I put a little nose and a mouth on one of the variations I did on the Fusion 360 design series, people didn't like that, so each to their own. You need a battery connector and a 9-volt battery. There are other options available. We could probably do an entire episode on batteries, because the 9-volt battery in the original design doesn't lend itself to easy accessibility or maintenance, because once you've put the motor holders in place and that battery's in there, it's quite difficult to get that out. So that's one of the things that we could probably look at. And then you need the motors. So I think I've got some just behind here actually. Where have they gone? Oh no, are they on the desk? Are they about somewhere? I'm sure I had one just to hand. There we go. That's these little fellas, and they come in all kinds of speeds. So this little gearbox on here can make it faster or slower, and more torque or less torque, so more pulling power or less pulling power. And that was one of the things I thought that's what I needed for the forklift. It actually needs one that's got a great big long spindle on it, about 55 centimeters long, about. So I had to order that very quickly, and also had a screw thread on it rather than just the little notch that one has. So you need 2 of them for your Smars. I would recommend the 150. That seems to be a good mix between speed and power, as Jeremy Clarkson would say. If you get the ones at like 300 RPM, it just ends up tearing itself apart and being a bit too fast. But if you're building a speed machine, maybe that's what you want to do. Definitely recommend gluing in your tracks if you're going to do that kind of speed, though. Makes it a little bit uncontrollable. So that was that. Then we had the Arduino Uno. We need a clone or something similar. Again, other options are available. You can use ESP32s, ESP, was it 8286? 8286, I can't remember what the letters are, but yeah, one of those, Node MCU or microbit. There's all kinds of things that we can use as the sort of brain. The feather, what's the Tinker thing? I can't remember what that's called now. There's a very fast Arduino that you can get. And yeah, the motor shield itself, of which again there are several varieties, and we've sort of covered that already. So you need quite a few different parts. I've made them available on smarsfan.com if you just want to grab them. I think Kevin Thomas has also got links to that on Thingiverse as well if you want to go there, whichever you prefer. That's all good. And let me just go back to Keynote there so I can see what I'm doing. And then equipment. So yeah, you either need a 3D printer or you need to use a 3D printing service. You need some filament to print out on. You need some soldering iron, flux and solder, wire cutters, DuPont connectors, which are these wires that enable you to plug things in. These are DuPont connectors. The things that plug into the top of the rangefinder. And again, you need a range of them, depending on, let's put that back in there. You need a range of them depending on what kind of motor shield you've got, and if it's got dedicated headers, are they female, male headers, that kind of thing. And these come in your pack of 3, so you get male to male, female to female, and male to female. So they're DuPont connectors. You can make your own, but I would recommend against that. We did cover that off actually in that video. And a USB cable as well. So whatever kind of USB cable is required to connect your Arduino to your computer. So I have a Mac. I have to use, let's see if I can get this on screen actually. So I have to use a little converter thing, if you can see that. So that's a USB-C, USB-C connector, because Macs nowadays don't have the old USB 2 or 3 connector, which is that one there. So I have to use like a little connector. And then the Arduinos that I have, I've got the USB, is that USB A? A or B? I think it's A. So yes, they have to use them kind of connectors. So whatever kind of cable it takes you to get connected upon there, that's what you need. And then we, which code to load, we looked at all different types of code that we can use there. So there is the movement code, which we looked at in the, Arduino programming series. So we looked at moving it backwards and forwards, left and right. We made a little avoid program so it would detect things with the rangefinder, and it would if it detected something, it would sort of back up, turn around, and go the other way. We did a remote control one, which was really fun with Bluetooth and a mobile phone. That was a lot easier than I thought it would be. So if you want to do that, it is really easy to do. There is just a few gotchas which will really frustrate you. So watch that video if you want to know how to do Bluetooth. There are some quirky things, like if you have an iPhone, you have to have the HC09 or 08, I think it is. Anything beneath that doesn't work, and it's just to do with a licensing thing that Apple have with Bluetooth providers, so it's a thing. We looked at the line follow as well, so we had it following around a path, and I printed out all different types of tracks. So on that video there's links to the track pieces as well that you can print out, so if you've got some kids and you want to design a sort of assault course for your Smars, that's a really good fun one to do. And then we looked at the the servos and using servos, and that will certainly be something that we'll be looking at when we come to do the quad robot, making that walk, because it's all about the servos. So the PCA 9685 board is the board at the back of the robot. So it's the thing, if I just pull this one up here, it's this thing that's at the back of the quad robot that's got all these servos plugged into it. So it's got a bit of a cover over it there, but you can just about see all the things there, and that's where the power goes in as well. So we'll come to that from next week onwards. And then we looked at the MPU 6050 and the /GY 271, which are all positioning sensors. One of them has a compass on there, digital compass. The other one doesn't. I think they all do gyro and acceleration. Some of them also do like height, altitude, like barometric pressure as well. So they're really interesting, but a bit fiddly to get working. You've got to keep them away from the motors, was the lesson that we learned on that one. And next step, so yes, the add-on module. So I asked you guys what you think I should build next, and as well as a robot arm, you also said the forklift module. So I was like, mission accepted, I shall give this one a go. I've always wanted to do this one as well. No idea what was involved in doing it, so I started printing the parts. And that was not as easy as it should have been. Let me show you some of the disasters that happened. So, first of all, I was printing out the piece that, I'll just show you here. This piece here, this is where the thing had printed and then stopped halfway through because it ran out of filament, and I just managed to stuff filament in just in time for it to carry on. However, it was just like hair holding this thing, together. So that thing did that midway through the print. Was a write-off. It should have looked like that. So you could just see just how close it was to finishing. So frustrating. So there was that one. Then I wanted to print the screw thread. So the screw thread, which you can let's make sure you can see me there. Yeah. So the screw thread. There we go. This obviously goes in the middle of the forklift and makes the fork move up and down. Should have been a really easy thing to print, but again, no. My printer wouldn't have this. It got to this height, which is like not even a third of the height that it should be. I'm just trying to put all these together here so you can see. It was at least 4 runs. There's another one, and it just ended up with this big blob of filament on the top. It just didn't seem to like to do this for any length of time. I don't know if it's a height thing, so I thought, oh, okay then, I'll print it flat. And this is what happened when I printed it flat. So, yeah, it's sort of gone all tapered at the end. That's not going to work as a screw thread. And, the end there as well, that's supposed to be sort of hexagonal, and is it going to focus on that? See if we can get it to focus on the end. Yeah, you're supposed to be able to fit a hex nut in there. There's no way that's going to work. So it printed it reasonably quickly, but utter write-off. And then the one that it actually printed in the end, it's good enough. So this has to go into this component. So let's go to the overhead shot. That's probably easier. Let me just bring you with me with the microphone. So, yeah, this goes into this part here. There's a bit of a countersunk thing so that it's nice and flush. You can see I've glued in there a little nylon locking nut, I think they call one of those things. Self-tapping thing. So that goes in there nice and flush, and then it's supposed to have just a little thing that pokes up into the other hole, but you can put a screw in there anyway just to lock it in place. So that's going to be good enough for what we need. So they were the first 2 parts. Then the next couple of parts are where we put the servo in. So again, this one wasn't straightforward. So when Kev Thomas designed these servo holders, the servos that he has, this wire must come out of the side rather than the base. So the ones I have, it comes out right at the very back. So I've had to chip away just inside. Let's see if you can see that. Just inside there, there's normally a piece, and I've had to chip that away so that when I put these in, oops, let's just try that. This can slot in that little thread there, and it just nicely tucks it away like so. And then this piece here, this has got like a little notch on it there, and then it's got a hole on the other side, and the hole has got the, is it called the servo horn? So that will go across there. So these are not that easy to put in place. It's quite strong. So what I've found is a technique, you get that on there, you can push this slightly forward and then hook it underneath. That's how I did it last time. It just requires a bit of brute force just to get that over there. Let's just try this. If it snaps, then I'll print and pull out. There we go. So that's now in place there, and then we just get our servo horn, and it's usually they're usually defaulting at about 45 degrees, I think. So I can always take this off and change it if not. Great, just drop that on the floor. There we go. Let's try that again. So that's to go in there. It should just click into place. There we go. And then there's a teeny tiny little screw. So I just need to make sure I'm facing the microphone. It's very directional. If I look away when I'm speaking, it goes very quiet. So just need to screw that into place. More fingers and thumbs today. I'm trying to show you at the same time as doing it. It's not as easy as you think. What I'll do when I've got the new studio, I'll have what they call a confidence monitor right next to the where I'm working, so that I can actually see what I'm doing and just look at the confidence monitor rather than look at my hands, because I'm constantly having to look backwards and forwards at my screen. My screen's over my left shoulder at the moment. Good grief, this is not going to plan. Get in there. I think it's also because it's a crosshead screw. There we go. And I'm using a flat blade, but there we go, that's good enough. So now, there we go, that's it. Just make sure that servo wire is nice and tucked in. Okie doke. Okie doke. And then this thing here, I've already pushed this into place. So this is another part of the forklift. This is where the servo pushes onto, and we can see here that these wires are designed to tuck out the way there. There's a little bit of the side here that's notched in. You can see that notch just there. That's where these wires go. And then there's two diamonds. There's one there and one there. So I've just soldered up the motor wires as usual. So you can get that to be just like that. And then hopefully it should just push into place. No idea how that's supposed to work. Maybe we just need to pull that out there. And then it should, just again, a bit of brute force, just put it into place and lock into place. Yeah, I really don't understand how that's supposed to work. What am I doing wrong there? That doesn't look right at all, that to me. Maybe that has to go through there. It wasn't very clear on the instructions how to do this bit. It's all just like plug unit A into unit B into unit C, and unit C to unit D. It's all well and good, so I thought I would do a bit of a video on how to do this, just so I can remember for next time myself. Yeah, that seems to be a bit better. Very tight fit, but I suppose that's a good thing because it's going to be load bearing. I could probably do a better job of getting that into place, but that'll do for now. So you can see there that's now got that kind of range. And then on our Smars, so this is our hero bot we've been printing, we need to take off the rangefinder module and then slide this piece into place there. So that now we have, is that right? I think it maybe needs to be that way around. Yeah, I've done it upside down. Oh, let's just take that out. Like I said, it's useful to you to see the mistakes I make so that you don't make them. There we go, that looks better. It snapped into place, that's much better I think. Okay, yes, so that now slots into place. And what we're aiming for there is, if you look side on, we want this base piece to be as low as possible so that the forklift piece can pivot as low to the ground as possible. Right, so that's part done there. And then we have these three parts So this didn't print ideally either. So it looks quite nice there, but on the back side it's all kind of mangled. It's again good enough for what we need, but it's not ideal. It's not perfect. So it's good enough for what we need. What happened was when I printed it out. Let's come back to the screen for a second. When I printed this piece out, it tried to do some really clever things in Cura where it created like a tree shape. It's all like a weird organic thing, and it starts off as circles and they all sort of end up, you know, splitting across there. And again, because the bed wasn't particularly level when I did this, I mean, it looks quite smooth on the bottom. You know, they're quite nicely printed out. You can see they're quite smooth there. However, that base piece there, just awful mess. But it's good enough. So what we need to be able to do on this one is get this thread to go through it, which it does. So that's the important bit. As long as that can go through it, that's all we need. So it's quite a precision piece, that. Let's get back to our overhead. So what's going to happen is this is going to go into this bottom piece. This is going to go like that, so that it can slide up and down, and then this piece will go through there. Let's do that so you can see it. Like so. So now when that turns, it will screw that up and down. Like so. Now the bit that I haven't done yet is threaded this thread onto here. I suspect that's going to take quite a bit of doing, but let's at least attempt some of it. It's going to be very fiddly to do that. So like I said, I've already glued into place that locking nut. I don't know why that's hard to turn. I'll have to do it like that. And because it's a nylon nut lock, it's kind of designed not to move, so that's going to be fun. I think what I might have to do, but you can see what happens anyway. That clips into place there, like so, and that thread is going to go through there into that nylon nut, which is in the bottom, and there we go. I need to thread it all the way down. It's going to take quite a while to do. Let's just give it a quick go and see how long that will take to do. About halfway now. Alright, that's tight. A little bit more before it into place. No, that's not going any further, is it? So I'll do this build, I think, offline rather than trying to do this all on camera. I think that's going to be quite hard to do. But you can see the kind of thing that we need to do there. This motor in here, which is these two wires here. Actually, we could just do this. This is going to be a disaster. Let's give this a go. Just reverse the motor. Seems very slow. I'll put it out there. Maybe it's not getting the full power. I don't know. I'm going to hit the bottom in a second. Is it going to... Stopped. There we go. So that does work, and the servo we can see there, that's going to have to plug into part of the board, either one of these sort of headers, or if we've got the Fujimoto one, which is this one, this board here, sorry about that, this one here has some, I think they're there, some servo headers there, so maybe we can use that one to power it. So work in progress, that one. I was hoping to have it done a lot more, but like I said, I was actually waiting for a part to arrive from Amazon, and it came this afternoon a bit too late in the day for me to really sort of prepare something for you on that one, but I couldn't not show you because it's the forklift thing. How cool is that? So I'm quite impressed with how this is coming along. I can see how this thing is going to work, and mechanically it is working. I just need to sort of bolt pieces in place. I think there's a little screw needs to go into the top there, and this is a little bit loose as well, so I need to think about how that's going to get locked into place too. Cool. So let me see what else. Yeah, so on there you can see, let's move the microphone a bit there so I can see the screen a bit better. So yeah, what it says you need there, you need the 3D printed parts, which you can get, I'm not sure, I think you have to pay for that one. Not 100% sure. It might be a free one, it might be a paid for one. It's not very much if you do have to pay for it, and it's definitely worth it because it's a load of fun. You need the servo. It's just an SG90 regular servo, and it says a 55mm M3 60 RPM motor. That's exactly what I ordered there. I thought it was one of these regular motors, but it's not. It's got a much longer thread on it, and it hasn't got the notched thing on there. If you can see that on there, it's got like the little notch, just like the motor ones. It has an M3 screw thread on it, and that's because it needs to go onto one of these nylock nuts. Again, trying to show you something which is very small, nylon nut. So I just happen to have a box full of them. I was going to mention that. Let me just see if I've got it on screen there. I don't know about you guys, but I find myself buying these sort of packs from Amazon of just things that I will need. So I've got, M3, 4, 5 screws in all different kinds of lengths, nuts as well. I've got all kinds of washers and things like that, again in all different varieties. I've got the trusty watch repair kit, glasses repair kit. It's got the nice small screwdrivers, and I have a range of connection things that you can change for your screwdriver. This is one that my dog chewed. They really enjoy chewing this. It's absolutely shredded to pieces. This is from a company called McAleer in the UK that's now bust, so hey ho. So, studio update. I'm just going to give you a very quick update on where we're up to with the studio. So, last week we had laid some data cable pipe down into the garden, and as well as some armoured cable as well, so that we can get some power up to the base. And if I go over to the screen share, you can see what I can see too. So here we go, here's some pictures. So the picture on the left there is just the garden as it was left. You can just about make out there's a reel of armoured cable there, and there's also a blue pipe. This black cable here is the data cable. And on the right there, we've got some contractors sort of coming in, putting some decking steps in place, because that's going to be the entrance to when you go up the garden. The garden is just an utter mud bath at the moment. It's just horrible. You can't walk on it without just getting thoroughly wet through and muddy. And then we had the contractors come with the concrete, so that was a whole load of mess and fun. So you can see there some quite dramatic pictures of, they had to have two trucks that connected together. One had the concrete in, and it's not like the old ones where it was like ready mixed and it's like setting all the time. This is like, it's a compartment where there's like dry and stone and it gets mixed together in the funnel. And they had to have an entire pumping truck with all these massive tubes, and you can just about see on the left hand side there, there's sections and sections of tube that they had to put in place. And I was thinking, like, surely when they finish pumping all the concrete in there, this tube is going to be full of concrete. Yep, about 4 wheelbarrows full. So they had to sort of clear that out too. But the result is a nice finished base. It was raining the whole time, but it didn't really affect the finish too much, because You can set concrete underwater, can't you? It's not an issue. It's just, do you want a glass finish or do you want it to be a cat paw prints and all the rest of it? So on there, it doesn't look a very big space, but that's about 4 meters by 3 meters. It's just one of them fisheye lenses is making it so you can't quite see. And this is going to be the new robot lab. So this is why I'm so excited to share it. And you'll be able to see as it comes together, all the different things. Very, very soon, end of October, the actual build is taking place, and the people are going to come in and put the sort of log cabin thing together, and then the electrician is going to come and put the cable in. I'm going to do the data cable part. We're going to get some heating in there, some lighting. It's going to be really mint. So be a purpose-built studio just for creating more content. So like I said, I'm in this for the long haul. Stick with me and we'll go far with this. We'll take Smars as far as we can. So that's the studio update. So comment of the week. For that. So as you can see there, we've got this person here. I have to try and avoid my language because some children do watch this channel, even though it's not got the kid only tag on there, but I know some people do watch it. So there's a person there with a name who I can't pronounce. He said, nice work, let's grow together. Yep, that's what it's all about. I'll share my mistakes and my progress as we go. It's not all about the finished article being sort of shown. And also Christopher Picard. I'm a big Star Trek fan, don't you know, so where are we? You can see I got my Spock t-shirt on. So that's chimed with me. He can't choose his surname, can he? But he says, yep, thanks for the videos. Great instructions. Thank you. So he was that's my very garbled, mangled French. I'm sure I clicked on the translate thing to have a look at that. But it's great to know that we have people of all different places around the world looking at these and watching the videos. I really get a lot out of your comments and your interaction as well. So always make sure if you're watching this live or if you're watching this on replay, please do comment, please do like the video and, interact with me as much as possible. It goes a long way. And to that extent, actually, if I go back to my little screen share for a second. This is a little insight that I get from YouTube on the YouTube Studio. It shows me that over 50% of the people who watch this don't subscribe. So why not? Just click that like and subscribe button. Give it a thumbs up. Leave me a comment. If you don't like it, give me a thumbs down. Give me another comment. Tell me what you didn't like about it. Let me know how we can improve these things. The more engagement, the better, really. This is how this YouTube algorithm picks things up. So, please do like and subscribe. So hit that like button wherever it is it down there? Hit the subscribe button, hit the little bell. Yes, it took me ages to knock together that little animation as well, so just think about all the care and attention that's going into this video. I was brought up Catholic, so I do know Catholic guilt, though I am probably an atheist now, just as an aside. Convince me otherwise. So let's get back over to the screen share. So next week, I was thinking about, there are so many different things we can do with Smars. There is so many things we can do. I think we should look at the quad robot. What say you? So we could look at the Smars version 4, but seeing as we've just done the wheel Smars, I thought doing another one of them. We need to mix it up a little bit. And the walking one has got loads of different directions we can take it in. The fact that we can use a Raspberry Pi, we can use Python as a language, which I actually think is an easier language to learn than Arduino. It's less fussy. So, so Samuel's got a comment there. He says, could we eventually wrap everything up, like setting up the environments, GitHub, organising code, functions, follow me, track me? Yeah, I know exactly what you mean. Let's bring it all together in one place. That's what they've done with the Otto DIY walking robot. I've got a little green one that I've actually never loaded the code on that one. I printed it out, built it, all the electronics, but I've never actually done anything with it. But they have everything in one sort of super library of code. So I like the idea of that, Sam. I think that'd be something we could really do. I think one of the issues is how do we get it to choose which program to use? So that's something we can think about. We could have like a button on the top that we could attach. Maybe we need to think about how we could do that. So yeah, we could make it a kind of a complete thing. So someone says, yeah, like organising the code. Let's just bring that on the screen. To make a smart toy as complete and as stable for kids, just like a toy. So what do you think about how the Smars is as a robot at the moment? So it's kind of exposed there. I mean, nothing's dangerous. You can you can put these in your mouth and you don't get electrocuted, you just get a little buzzing sensation, but it's not exactly kid friendly, is it? So do we need to put sort of a lid on? But I think that sort of affects the aesthetics. I quite like it being raw and being exposed there with all the wires hanging out. I think it makes it look very much like a robot. Do you think we should have the covered variety? There is an add-on module that makes it like a space buggy that's got like a big lump on the top, and things like the batteries as well. I think we need to look at how we could improve the battery situation. So one of the reasons I did the Designing in Fusion 360 course was I wanted to give everybody the skills and also up my own skills by teaching people on how to create this from scratch so that we can then adjust it and make it our own. So one of the designs that I did was to put a little hole in the bottom there so you can open it up and get to the battery. Didn't quite finish that one, but that's an option. A lot of people like having the 18650 batteries. They're very, very popular, good rechargeable, plenty of power in them, but they're not really very well suited to this design. So someone says, yeah, it's safe, but loading and unloading code is not kid friendly. Yeah, so if we had some kind of like program selector. So this is what I was thinking with the quad robot, and we can certainly think about this with the wheeled one as well, is with Python we can create, because it's a full computer, we can like serve up a web page. So instead of having to have an app, and I created some code a while ago called Smars Lab, and this is what I'm looking to extend, and it's a full, I can show you now on screen, if you just bear with me while I just load up the page, because it is on smarsfan.com and it's on my GitHub site too. Let me just quickly find this and I'll just share the screen as well. So let's go to screen share and let's go to current application and let's go to Smars Fan. So let me just, machine's being very slow all of a sudden. Chrome seems to really kill my machine at the moment. This is not a small Mac either, it's quite a powerful machine, but when I'm running the live stream software, it has to encode 3 live streaming sources at the same time, and it doesn't seem to be optimized for that. There's another package called vMix which I might get, but that's Mac. That's Windows only. Let me just try and use Safari instead. That doesn't seem to be working. So what I'm trying to find here is smarsfan.com. Let's see if that's any better. There we go. So if we then go to, is it Play Smars Lab? Make sure I can see the screen there. And oops, let me just get. So if you message on there, it is actually me that you're speaking to, just out of interest. So this is what Smars Lab looks like. So you've got the controls on the left hand side, and you click forward, backwards, left, right, up and down. It makes the robot stand up, move forward, and you get all the telemetry information as well, all the angles that things are at. So and you can do things like clap and wiggle. So this was kind of an idea that I'd had. I've learned so much more now about Python and web interfaces and APIs and so on. I can take this definitely to the next level. We can really make this something easy to use for kids. And there's nothing stopping us from putting a Raspberry Pi Zero in a Smars as well. An Arduino is a nice easy starting place to begin with, but Raspberry Pis are cheaper. They're about £5 in the UK. It's about $6, something like that, to buy. Very, very cheap. If you get the one that's got the Bluetooth and Wi-Fi built in, that's not much more. It's probably about £4 more. And that means that you've got native Bluetooth, you've got Wi-Fi enabled. They do use a little bit more power, but they're so much more capable. So we could certainly do that, put all the programs together, and then it's just a button on this web interface, do the follow me code, do the line follow code, People have talked about getting it to detect modules. That's not that easy, because how would it know what's connected? But yeah, as Samuel says, power management for electronics will broaden the maker skills and knowledge on how to go on with best practices and powering their creations, power requirements versus battery for optimal battery usage and so on. So again, one of the things I've looked at and I have the kit for is wireless charging. So I've got 2 tuned coils with little circuits on, and you put 5 volts in one end and then the other coil will receive 5 volts if they're sort of aligned. So I was thinking in the bottom of our Smars we can have one of these chargers, We can have the LiPo battery inside instead of a 9 volt, and that's part of our power management situation solved. And there is lots of circuit designs which are very trivial, which you can monitor the actual voltage of. Is it 3.7 volts? Is it 4.7 volts? What is the actual battery voltage? And you can define that as a 0 to 100%. So you could make like a battery usage. So many things we can do with that, and I think we can do that easier with the Raspberry Pi Zero, but I'll probably have to convince you all and bring you with me on that one. But we can make this into a package, into a toy that's very friendly to use. Again, we need to think about things, things like these track pieces and the motors. Some of them could be swallowed by very young children, but for what, 7 and up, would you say? I think that will be fine. Sorry, my little rangefinder just fell off the head of this one then. So yeah, we can certainly do a lot more with that. And that's what I love about Smars. It's such a versatile and great design. We can do so much more with it. I don't think these videos will end. I think there's so many directions we can go in there. So that's what I thought about from the point of view of Smars Lab. Let me just get back to Keynote. And let me just put that on Keynote there as well. So yes, next week is going to be quad series. So you can see a little video I did there of the quad, and then here's one I did that's actually on my YouTube channel of the quad walking. Yeah, you can still hear me talking. So this one, it's got the Raspberry Pi sort of dangling off the back just off camera there, but you can see where it's supposed to go just within the normal Smars body. And it's a pretty regular Smars chassis. It's the one that doesn't have the wheel stubs on it, and then there's kind of a frame that goes over the top of it, which gives it a back and front connectors, and you can see the rangefinder isn't wired up there, but all the servos are, and it's walking quite happily. We did actually go through the walking code in one of the videos recently. I think, was it in the Learning Python series that we did? We did do the walking cycle, so we can pick that up and use that. And with Smars Lab, we can just drop that code straight in and have a nice web interface, so we can make it look and be able to be used over a mobile phone, because you can connect to it over like your local area network if the Wi-Fi is configured right. It does introduce a bit more complexity with it being a Raspberry Pi Zero, but we can solve that. For work, I've probably told you before now, I'm a project manager, but obviously I know computer geeky stuff, so I always bring a bit of that to my job as well. And they had a problem where they had this really old intranet site for all their pages and their news articles, tens of thousands of articles, and they had this brand new SharePoint 365 site, and they wanted to sort of take all the old news articles and put them on the new one. And I was like, yeah, you could write a Python program in about half an hour that could do that. So I did I wrote the program that could do exactly that. It would scrape off all the old text, convert it into Markdown, spit it out as like perfect HTML the other side, grab all the images, rewrite them, get rid of old URLs, all that kind of stuff. Python is such a beautiful language to do that kind of stuff in. So that's one of the things that Smars Fan has helped me with. It's sort of up my skills from programming. And Python's a great language for that. I find the Arduino, it's C as a language, and C's very fussy and yeah, it's not the best. But so someone was asking about not sure how to set up Visual Studio for Arduino, and this makes me not trust it. Yes, it's not intuitive to do that. You can set it up there, you can get it to do the uploading and downloading, but really the best tool for the Arduino is the Arduino IDE. So we could look up setting up an environment. And again, one of the things I like about Python is it's cross-platform. You can use it on Raspberry Pis, you can use it on Mac and Windows. All the libraries which are a problem on the Arduino are not a problem on Python, because you can create what they call a virtual environment, and you can specify all the libraries that you need to pull in. The person, when they're setting this up on a Windows, Mac or PC, Raspberry Pi or whatever, they don't need to worry about that. And we can even put MicroPython onto some embedded chips as well, so lots of things we can do with Python. So I think it's definitely a language that's easy to get into. There's even things like the code blocks that you can visually program if you're not familiar with how to do that. And programming is all about mindset. If you have an Apple iPad, they have a great series on there. I mean, the language is Swift. So don't worry too much about the language itself, but it's the mind, the thought processes that go behind programming that most people can't crack to begin with. And you just have to think like a computer. So we can get into that. We can look at how to come across problems, how to solve some problems, and maybe have some challenges and so on. So these are all future directions that we can take in. This is why I'm really excited about getting the studio where we can combine the 3D printing, the electronics part, and the coding to bring all this together. So this is what I'm all about building these robots together with you, bringing them to life with code, and having a whole load of fun along the way. So I think that probably wraps it up for this episode. Thanks everybody for watching along. I've really enjoyed your company. Thanks Sid and Samo who've been with me on this video today. And thanks everybody who's watching on replay. Don't forget to subscribe as well, you guys. So see you next time. Thanks everyone. Bye-bye.
I try so hard to fade away, but something's forcing me to stay. It'd be easier for me if I turn away to flee. Oh, but there's something holding on, the way of being long gone. There's so many ways to escape, but I guess it's time to wake up, time to wake up. Far too many